Welcome to STEM Kits from iBio Institute and to your experience in gravity and simple robotics.
This video will guide you through the building of a simple passive dynamic robot which uses gravity to walk. You will test one that you build and then you'll redesign it to do a better job. Lastly, you'll defy gravity to build a standing arch. My name is Kathy.
And I am Grace. This video will help to guide you through this engineering challenge. Engineering is the application of scientific processes and concepts to solve everyday problems. What makes this different from other problem-solving processes is the way engineers plan and execute their investigation. They carefully change one aspect of their design at a time so that they can clearly tell what actions make a change. Engineers also take the time to carefully record their observations and measurements so that others can easily understand and repeat their design. In this challenge, we will use this process to improve the design of a passive dynamic walker.
All of the experiments you're going to do today are going to utilize gravity. So the first thing we need to know is, what is gravity? Gravity is an invisible force that pulls objects toward each other. That's why a ball that you throw will always fall down. It's why a person who parachutes from a plane will always fall back to Earth. Gravity pulls them down. We have been studying gravity for a very long time. One of the things we have learned is that the bigger the mass of an object is, the harder it pulls on other objects, particularly small objects. In order to defy gravitational pull to float or to fly, an equal or greater force will need to push in a direction opposite to the force of gravity, pulling it to the Earth. This makes gravity a very powerful force. Scientists who are on a search for green energy sources are finding ways to use gravity to generate electricity, like the tower you see in this picture. Gravity pulls weights that turn turbines on a generator that produces electricity. Now that's creative engineering. In our engineering challenge, we are going to find ways to power robots with gravity. Although originally robots were designed to look like humans, in real life they can take on many forms and be used for many purposes, like this vacuum or this flying drone. We actually have cars that drive themselves. We have worker robots that build things for us. And we have robots like the Mars rover that goes to planets that humans cannot visit yet to explore, experiment, and send back pictures to Earth for us to analyze. Today, you will be building a robot called a passive dynamic walker that uses gravity to power it. When it is set on an inclined surface, this walker will begin moving down to the end of the ramp, with gravity powering it all the way. There are many ways to design these walkers, many materials, shapes, and sizes, and engineers have been able to make robots that are very simple and energy efficient by studying this design. So the first thing that you want to do is get all of your materials organized. You are going to need your wooden beads. You're going to need a sharpened pencil, your scissors, 2 small craft sticks, a wooden skewer, some self-adhesive foam, and a template of walking legs. There's some extra space on there so that you can build your second robot.
The first thing you're going to do is grab a pair of scissors and the leg template that we provided you. Use the scissors to carefully cut out the pair of legs on the template.
Next, you're going to use your sharpened pencil and you're going to punch a hole in the leg where it is drawn, just like this.
Okay, so the next thing that we need to do now that we have holes in the legs is we want to make sure that they swing freely. So we're going to use the skewer, which is going to help us with our walker, and we're going to put the legs on the skewer. And you can see they kind of get caught. So I'm going to use the skewer to kind of make the hole just a little bit bigger just by working it around, or I can actually take it off and put the pencil in again. And I'm going to put it on here to make sure that it swings freely.
Remove one leg, slide a bead onto the middle of the skewer. Then replace the leg on the other side of the bead. With the toes pointing toward you, fold one foot out to the left and the other foot to the right.
The next thing you're going to do is make sure your legs are strong. You will need to measure and cut out 2 pieces of craft foam the same size as the bottom of each foot. Once they're cut out, stick them to the base of each foot. This is going to help you with traction. Then use a glue stick to attach a mini craft stick to the top of each foot like we're doing in this video. Make sure it sticks out a little bit more in the front like a ski. This is going to help you with swing. In the end, it should look similar to our picture below. Next, we are going to make the shoulders. You want to make sure that when you're putting the tape on that it's a little bit tight, but you still want the legs to be able to swing. Don't worry if you don't get it perfect the first time because you can always take the tape off and move it later. That's why it's really helpful to do what Aureli's doing in the video and do it with one longer piece of tape so that it hopefully swings the first time like this.
Okay, so Aurelie is going to put the hands on her robot. She's already slid beads on both sides and balanced them out. You can see that they're there, and she's just going to anchor those in place with some duct tape so that they don't move. And she's getting one side all set up, and she's basically going to do the same thing with the inside part of that bead that she did with the shoulder beads. She's going to wrap that around, and then she's going to do the same thing on the other side.
All right, now that you've watched us make our robot, it's time for you to try it out and make yours. Pause the video now so that you can follow the procedure on the screen to create your very own robot. Once you've assembled your robot, you need to test to see how well it works. You will need to make a slanted ramp similar to the one that's on the screen and set your robot on the top. Gently tap one end of the skewer, and the robot should move side to side as it makes its way down the hill, just as you see them doing right now. Every robot and ramp is different, so you may need to adjust your beads and tape a few times before your robot is able to walk well. Remember, engineering is all about making small changes so that you can better understand what specifically makes your robot walk better. This will help us later on in our challenge. After adjusting your robot so that it walks well down your ramp, you will be testing the effectiveness of your robot by measuring the time it takes to move down the ramp and how straight it walks down the ramp. To test time, start a timer when you start moving your robot down the ramp, and stop the timer once it reaches the bottom. To test how well it walks in a straight line, either draw a line or place a piece of tape down the center of your ramp. Start your robot at the top of the ramp on top of the line you just made, and then once it reaches the bottom, use a ruler to record how far away the robot is from that line you made. You can use centimeters for this. Test each of these 3 times and record your results in the data chart. Then you can calculate the averages so you know how well your first walker went down the ramp. Now that you've made a basic walking robot, let's try to make a second one that moves faster and walks straighter. Think about what problems you had with your first one. How can you redesign it using the same or different materials? What changes need to be made? What needs to stay the same? Does it need different sized legs? Maybe more legs? Maybe more beads? This is your time to engineer your own robot. In your packet, draw out a label diagram and write down what materials you're going to need. Remember, engineering is all about recording the changes we make along the way. Once you've designed and built your new walking robot, it's time to test it. Don't forget that it's always okay to make adjustments before you officially start your tests. We're going to use the same tests as before so that we can see if your new robot is faster and walks straighter in the same situation as your first one. This is how engineers check to see if the changes they've made are actually effective. As you do your tests, remember to record the results in your data chart. Did it do better than your first robot? Take a look back at the data chart for your first robot to compare. We've spent a lot of time today using gravity to move our walkers down ramps. Way to go! But now it's time to use gravity in a different way. We're actually going to use it to hold something up.
Stone archways seem to defy gravity. The heavy stone should fall to the ground when gravity pulls on it, but it does not. This has to do with the design of the bricks. This last activity, you will be building some bricks that are specially shaped so that you can build your own gravity-defying archway.
Today, we're going to be building our archways with bricks. Cut out each of the 6 brick templates and fold along the solid lines. You want it to be as perfect as possible so that each brick looks identical. This will help keep your archway stable. Once you've made your folds, secure each brick structure carefully with tape. Next, we're going to cut out our sandpaper strips and glue them to each brick on the sides that are labeled with a small rectangle. These strips are going to help us create friction. Friction is the resistance that keeps our bricks from sliding as we create our arch. Once the glue is dry, it's time to build our arch. It might take a few times to get your archway up and maybe even a buddy, but let's face it, defying gravity is no easy feat. Thank you for joining us for our engineering challenge today, and I hope you had fun. STEM kits are a product of iBio, delivering industry-led STEM programs for teachers and students to inspire a new generation of innovators and entrepreneurs. To learn more about iBio and its programs, visit www.ibio.org.